Would you build the future around a rocket that hasn't proven it works? Most of us wouldn't, but that's exactly what's happening. NASA's return to the moon depends on Starship. Private companies are designing missions around it. Entire programs are moving forward as if its success is already guaranteed. How did that happen? I thought the answer would be hidden inside the rocket. I was wrong. To understand how that became possible, we have to look at what changed first. Because it was not the rocket. The more I looked, the stranger it became. For decades, the pattern had always been the same. A new rocket proved it could fly. It proved it could keep flying. Only then did governments begin building long-term plans around it. That felt so obvious I almost stopped questioning it. Then I opened NASA's Artemis architecture. I expected to see a future built around rockets that already existed. Instead, one vehicle kept appearing over and over again. Starship, not as a distant possibility, not as a backup option, as part of the plan itself. That caught me off guard. NASA was not waiting to see whether Starship would eventually succeed. Its first crewed return to the moon already depended on a version of Starship designed to carry astronauts from lunar orbit to the surface. I wondered if that was simply one ambitious mission taking a calculated risk. But the deeper I went into Artemis, the harder that explanation became to defend. The architecture did not treat Starship as a one-time experiment. Future phases continued, assuming more capable versions would already exist. That was the moment the question changed. This was no longer about whether Starship might become important. It was about why so many long-term plans were already behaving as though it would. And NASA was not the only one. The same assumption was beginning to appear in commercial lunar projects and long-term exploration concepts. Different organizations, different goals, yet they were all planning as if the same piece of the future had already arrived. The biggest change was not happening on the launch pad. It was happening on drawing boards, inside planning documents, and in decisions being made years before the rocket had completed operational service. Once I realized that, a much bigger question appeared. Why would experienced engineers and space agencies accept that level of commitment before the technology had fully proved itself? At first, I assumed NASA had simply become more willing to take risks. That sounded like the easiest explanation. Then I started looking at what Starship was actually expected to do. That was when I realized this was nothing like the lunar landers that came before it. During Apollo, the lunar module had one job: carry astronauts from lunar orbit down to the surface, then bring them back. It was built for a single mission, a single destination, and a completely different architecture. Artemis could have followed that same path. Design another dedicated lunar lander, keep the system separate, keep the risks contained. Instead, NASA chose something that looked almost impossible. A version of Starship, not a small spacecraft built only for the moon, a vehicle derived from the same system SpaceX was developing for far bigger ambitions. That surprised me, because NASA was no longer betting on just one spacecraft. It was betting on an entire transportation system that was still under development. The more I compared it with previous lunar programs, the stranger the decision became. Government space agencies had always preferred mature systems for missions this important. That approach had decades of history behind it. Yet here was NASA building its return to the moon around a commercial vehicle that had not reached operational service, even after development challenges pushed schedules back. The architecture stayed remarkably consistent. The agency kept refining the missions around Starship instead of abandoning the idea altogether. That was difficult to ignore. This no longer looked like optimism. It looked like confidence. Not confidence that everything would go perfectly, confidence that whatever Starship could eventually become was important enough to keep building around. So I stopped asking whether NASA had accepted unusual risk. A more interesting question had taken its place. What made Starship valuable enough that the world's largest space agency was willing to redesign its future around it? I assumed NASA's confidence must come from performance. Bigger payloads, more power, better engineering. But the deeper I looked, those explanations kept giving way to something else, again and again. The conversation drifted toward transportation costs. Starship was not being judged only by how much it might carry. It was being judged by what repeated reuse could eventually do to the cost of every launch. That sounds like a small difference. It is not. Imagine building a city where every truck is so expensive that every delivery has to be justified. The city would grow cautiously. Now imagine transportation suddenly becomes cheap enough that moving goods is no longer the main constraint. You would redesign the entire city. That was the possibility engineers kept returning to. If a launch vehicle could fly again and again, instead of being built for every mission, the economics of spaceflight would begin to change. And once transportation economics change, the questions engineers ask begin to change as well. Instead of asking whether something is too heavy to launch, they can start asking whether it should be built differently altogether. That realization completely replaced my original assumption. Maybe Starship was never important because it was the biggest rocket. Maybe it was important because it challenged the cost of getting anything into space. And if transportation costs really changed that much? Another question became impossible to ignore. What happens when rockets stop adapting to missions, and missions start adapting to rockets? That question changed the way I looked at every future mission. I had always assumed engineers started with a destination. Then they figured out what kind of rocket they needed. That was how spaceflight had always worked. The mission came first. The launch vehicle followed. But the more future lunar projects I looked at, the harder that rule became to defend. Some concepts no longer began with existing rockets. They began with a different assumption. What if transporting enormous amounts of cargo to the moon became routine? Once that assumption changed, everything else followed. Habitats grew larger. Power systems expanded. Supply deliveries stopped looking exceptional and started looking continuous. I almost missed what tied all of those ideas together. None of them depended on a scientific breakthrough. None required a new discovery about the moon. They depended on transportation. If sending large amounts of equipment became easier, engineers no longer had to design around scarcity. That single change removed a constraint that had shaped space missions for generations. The rocket was no longer just carrying the mission. It was quietly redefining what engineers believed was worth designing in the first place. The relationship had started to reverse. Instead of asking which rocket could support a mission, planners were beginning to imagine missions that only made sense if Starship-class transportation became available. That realization stayed with me, because if one transportation system could reshape the way engineers imagined the moon, there was no reason the change would stop there. The next question almost asked itself. If transportation was becoming the foundation of every future plan, who else was already rebuilding their future around the same assumption? Until this point, I was still thinking about rockets. Bigger rockets, cheaper rockets, more capable rockets. Then I realized I was asking the wrong question. History tends to remember space exploration through individual missions. Apollo, the Space Shuttle, the International Space Station, each one feels like a separate achievement. But the people planning the next era of exploration were increasingly talking about something else. Transportation itself. That surprised me, because missions come and go. A transportation system stays. And once it changes, every mission built on top of it changes as well. I started noticing the same pattern everywhere. Instead of asking how to reach the moon one more time, planners were asking how to keep reaching it. Not with one spectacular landing, with a steady flow of cargo, equipment, supplies, everything needed to support a long-term presence. That completely changed the scale of the story. A single mission only has to succeed once. A transportation network has to work over and over again. The economics become impossible to ignore. Every kilogram launched from Earth affects everything that happens afterward. Build a habitat, deliver a rover, replace a broken system, expand a research station. Transportation quietly influences every decision long before anyone steps onto the surface. That was the moment everything connected. Lower transportation costs were not simply making existing missions cheaper, they were allowing entirely different exploration strategies to become realistic. The real disruption was not another trip to the moon. It was the possibility of treating space less like a series of isolated expeditions and more like a place that could support continuous activity. And it raised another question. If transportation economics could reorganize the plans of governments, who would be the first to move even faster? Up to this point, I assumed governments would benefit most from this shift. Then I looked beyond NASA. Some of the boldest long-term plans were coming from private companies, not because Starship had already transformed spaceflight, because they believed it eventually could. That distinction changed everything. The pattern appeared, one proposal at a time. One company assumed future stations could receive far more cargo than previous generations. Another explored manufacturing in orbit that only becomes practical if transportation costs fall dramatically. Others began sketching logistics networks that assumed regular movement between Earth and orbit. Different businesses, the same underlying expectation. I noticed something all of these ideas had in common. None of them depended on one spectacular launch. They depended on routine transportation. That completely changed how I saw the commercial side of space. These companies were not chasing a bigger rocket. They were preparing for a different economy, one where sending large amounts of hardware into orbit was no longer the rarest part of the business. That was a subtle shift, but it changed everything when transportation becomes cheaper and more frequent. Entirely new businesses become possible, not because engineers suddenly become more creative, because the rules they have to work within are different. The strange part was that many of these businesses did not exist yet. They were planning for a future that had not fully arrived. Just like NASA, that was becoming a pattern I could no longer ignore. People were not waiting for the new reality. They were building their plans around the expectation that it was coming. And if governments and private companies were already changing direction, there was one group that could not afford to stand still. What would the rest of the launch industry do if they believed the same future was approaching? I expected competitors to wait. Instead, many of them were already changing direction. Not by copying Starship, by preparing for the kind of market Starship might create. Only then did the individual strategies begin to make sense. The conversation was no longer centered on building slightly more powerful rockets. It was increasingly centered on reuse, lower operating costs, higher launch frequency. The same themes kept appearing, even though each company was pursuing them in a different way. That surprised me. Competition was no longer centered only on the next launch contract. It was becoming a bet on which future would arrive. Building rockets takes years. Rebuilding an entire business takes even longer. That meant companies had to prepare long before certainty existed. Even companies that were not building Starship still had to respond to the possibility that its economics could become real. Ignoring that possibility was a strategy of its own, and it might be the riskiest one. Every company was making different technical choices, but many of them were preparing for the same future. Not because that future had already arrived, because they believed it could. That completely changed the way I thought about competition. The race was no longer only about building the next rocket. It was about deciding which future was worth preparing for. And that raised the biggest question yet. If so many organizations were already planning around the same assumption, how much of humanity's future in space was already depending on it? Up to this point, I was still thinking about what Starship could do for SpaceX. Then I realized that was far too small. The more I followed NASA's long-term plans, the more obvious it became that this was no longer about one company. It was about everything built on top of the transportation system. Artemis was never meant to end with a single landing. The long-term vision included habitats, large rovers, surface equipment, cargo delivered again and again. Every one of those ideas becomes easier to imagine if moving massive amounts of hardware to the moon becomes practical. That completely changed the stakes. A new rocket normally affects the missions it flies, This was different. Future lunar infrastructure was increasingly being planned around the assumption that transportation on this scale would eventually exist. The rocket was becoming part of the foundation rather than another vehicle in the fleet. One question kept interrupting every conclusion I reached. What if this assumption proved wrong? Delaying a mission is one thing. Building an entire exploration strategy around the wrong transportation model is something else entirely. That possibility made every planning document feel different. I started thinking about Starship as a planning assumption, an assumption that was quietly shaping decisions years before the technology had fully matured. And that led to the final question. Had the real transformation already happened before a single operational Starship mission ever existed? When I started this investigation, I thought the biggest question was whether Starship would eventually work. By the end, that no longer felt like the real story. The evidence pointed somewhere much larger. The real change had already begun. Not on a launch pad, not after a successful mission. Inside planning meetings, procurement decisions, mission architectures, long-term roadmaps. Governments were planning for it. Commercial companies were planning for it. Engineers were designing around it. None of them could know exactly when Starship would reach full operational service. None of them could guarantee the ambitious projections would become reality. Schedules could change. Development could take longer than expected. Many of the promised economics still have to be proven in regular operation. And yet the planning continued. That was the part I could not ignore. History usually recognizes a technological revolution after it succeeds. This one was already changing planning, investment, and exploration strategy before reaching operational service. The unfinished rocket was never the biggest story. The biggest story was that humanity had already begun designing its future around the possibility that transportation itself was about to change.